Trigonometric ratios, the unit of a circle. Below is a unit circle drawn on a Cartesian plane. A unit circle is a circle with radius of 1 unit shown below. X and Y axes divide the circle into 4 sectors called quadrants. The first quadrant is A, second B, third C, and fourth D. On a Cartesian plane, angles are always measured on the x-axis on the positive side. Angles measured anti-clockwise are positive. Angles measured clockwise are negative. This is illustrated below. Angle UOV is plus 75 degrees since it is measured anti-clockwise. Angle VOW is minus 30 degrees since it's measured clockwise. Note that angles are measured from the x-axis only. Thus, a complete clockwise turn is minus 360 degrees. A complete anti-clockwise turn is plus 360 degrees. For example, show on a unit circle 30 degrees and minus 250 degrees and indicate which quadrants they fall. The solutions are indicated below. Trigonometric ratios in a unit circle. Consider the circle below. The arc PR subtends an angle theta at O. Perpendicular line from P meets OR at Q. Thus, POQ is a right-angled triangle. Finding trigonometric ratios for theta. Sine theta is PQ over OP, which is PQ over 1. Note that OP is the radius of the circle, which is 1 unit. PQ is the y-coordinate of point P. Cos theta is equal to OQ over OP, which is equal to OQ over 1. And this gives us OQ. Note that OQ is the x-coordinate of point P. Tan theta is equal to PQ over OQ, which is also given as y-coordinate over x-coordinate, which is equal to sin theta over cos theta. Consider the figure below. If an angle of 30 degrees is constructed on a unit circle, the coordinates of P will always be 0.87, 0.5. Let's see the trigonometric ratios of such an angle. Sin 30 is equal to 0.5 over 1, which is 0.5, and that is the y-coordinate at P. Cos 30 is 0.87 over 1, which is the x-coordinate at P. Tan 30 is sin 30 over cos 30, which gives us 0.5747. Use your calculator to confirm the above. Draw other unit circles on a graph paper. Construct any angle on the circle. Take the coordinates at P and try the ratios as we have done. Use the calculator to confirm it. ratios of angles greater than 90 degrees. In a unit circle, x-coordinate gives the cosine of an angle, y-coordinate gives the sine of an angle. Y over x coordinates gives the tangent of that angle. We can use the unit circle even for angles greater than 90 degrees, like 120, 240, and 330. Consider the figures below. 120 degrees is in the second quadrant, 240 in the third. For 120, the coordinates of P are negative 0.5, 0.87. Hence, cos 120 is x-coordinate and is equal to minus 0.5. Sin 120 is equal to the y-coordinate, which is equal to 0.87. Tan 120 is y-coordinate over x-coordinate, which is equal to 0.87 over minus 0.5, giving us minus 1.74. For 240, the coordinates of P are minus 0.5, minus 0.87, and hence we have cos 240 is 0.5 minus, sin 240 is minus 0.87, and tan 240 is 1.74. Use the unit circle to construct an angle of 330. Take the coordinates at P and you will find that P will be 0.87 minus 0.5. Hence we shall have sin 330 is minus 0.5, cos 330 is 0.87, tan 330 is minus 0.57. In short, in the first quadrant, all trigonometric ratios are positive. In the second quadrant, sines are positive while cosines and tangents are negative. In the third quadrant, tangents are positive, cosines and sines are negative. In the fourth quadrant, cosines are positive, sines and tangents are negative. This is illustrated by the unit circle below. Any angle greater than 90 can be expressed in terms of its deviation from 180 degrees or 360 degrees. For example, 120 degrees is equal to 180 minus 60. 260 degrees is equal to 180 plus 70 degrees. 320 is equal to 360 minus 40. The following is true about trigonometric ratios of angles greater than 90 degrees. For example, use the unit circle to find the value of sin 140 and sin 265. Sin 40 degrees is equal to 0.643. 140 degrees is equal to 180 minus 40. Therefore, sin 40 degrees is equal to sin 180 minus 40, which is equal to sin 40, and that is 0.643. For the case of B, sin 85 is equal to 0.996. 265 degrees is equal to 180 plus 85. Sin 265 is therefore equal to minus sin 180 minus 85, and that is minus sin 85, which is minus 0.996. Just a small quiz. Given that sin 45 degrees is 0.71 and cos 35 is 0.82, tan 55 is 0.20, find sin 225, cos 145, and tan 305 in your own time. Over to ratios of negative angles. Negative angles are measured from the x-axis in a clockwise direction. Consider the angle negative 78 degrees illustrated below. We then take the coordinates of S and proceed as usual. Trigonometric tables. We can use these tables to find the ratios of angles greater than 90. For example, sin 240, cos 330, and tan 120. In our solutions, 240 degrees is the same as 180 plus 60, and therefore sin 240 is the same as negative sin 60, which is negative 0.87. Similarly, cos 330 is the same as the cos of 360 minus 30 degrees, which is also the same as cos 30, and it gives us 0.87. Tan 120 is the same as negative tan 60, which is minus 1.74. Angles greater than 360 degrees. For such angles, we simply find their deviation from 360. We then find the ratios of the obtained angles. The examples below illustrate this. Consider 390 degrees. 390 is the same as 360 plus 30, and thus 390 is in the first quadrant. 540 is the same as 360 plus 200 degrees, and therefore it falls in the third quadrant. For example, find sin 480 and cos 510 degrees. In our solution, 480 degrees is equal to 360 plus 120. We find sin 120, and we know that 120 is the same as 180 minus 60. Sin 120 is the same as sin 60, which is 0.87. The same case is applied for 510 degrees. Moving on, we look at the radian measure. Angles can as well be measured in radians. 1 radian is the angle subtended by an arc that is equal to the radius of the circle. Consider the figure below. Angles in radians are given the unit theta with a superscript c. Size of an angle in radian is equal to ratio of arc to radius of the circle, that is, theta is arc length over radius. For the case above, it is AB over R. Radians and degrees. If an arc AB subtends an angle theta at the center of a circle of radius r, then theta is equal to AB over r radians. Recall that circumference of a circle is given by 2 pi r. 2 pi r is the length of the entire circle. Therefore, the angle in radians is that of a complete circle, which is given by 2 pi r over r, which is equal to 2 pi radians. This means that 2 pi radian is equal to 360 degrees, since a complete circle has an angle of 360 degrees. Pi radian is 180 degrees. Given pi is 3.142, then 1 radian is equivalent to 57.3 degrees. When angles in degrees are expressed in radians, the term pi is used. For example, 45 degrees, 60 degrees and 120 degrees expressed in radians, we shall have 180 degrees is equal to pi radian. 45 degrees will therefore be equal to 0.25 pi radians. 60 degrees will be equal to 0.33 pi radians, and 120 will be equal to 0.22 pi radians. Let's take one example. An arc of 1.9 centimeters subtend an angle of 0.31 radian. Find the radius of the circle. We've seen that theta in radian is equal to s over r, where s is the arc length. Therefore, 0.31 is equal to 1.9 over r, and our r is 6.13 centimeters. Trigonometric graphs. Given the ratios y is equal to sin theta, y is equal to cos theta, and y is equal to tan theta, we can plot the graphs using the values of theta with the corresponding values of y. For example, y is equal to sin theta. We make a table of values for theta and y. The table of content will appear as shown below. If we plot corresponding values and join the points to make a smooth curve, we shall obtain the graph shown below. The same principle is applied for y is tan theta and y is equal to cos theta. Note that two graphs can be plotted on the same axis. For example, on the same axis, plot the graphs of y is equal to sin theta and y is equal to cos theta for values of theta between 0 and 420 degrees. Use the graph to find theta when sin theta minus cos theta is equal to 0, cos theta is equal to 0, and sin theta is equal to 0. In our solution, using the above tables that we already had, we can have the following graphs shown below. In the solution, sin theta minus cos theta equal to 0 means that sin theta is equal to cos theta. These are all points of intersections of the two graphs, and that is 45 degrees, 225 degrees, and 405 degrees. Cos theta is equal to 0 is all the points where the graph of y is equal to cos theta cuts the x-axis, and that is 90 and 270 degrees. For sin theta equals 0, it is the point at which the graph of y is equal to sin theta cuts the x-axis, and these values are 0 degrees, 180 degrees, and 360 degrees. Moving on, let's look at sine and cosine rules. Let's start with sine rule. Consider the figure below. ABC is a triangle with dimensions A, B, and C. Please note how the sides are labeled with respect to the vertices of the triangle. Now, A and B is a right-angled triangle. Sine B is equal to AN over C, meaning AN is equal to C sine B. Equation 1. ANC is also a right-angled triangle. Sin C is equal to AN over B, meaning that AN is equal to B sin C. Equation 2. From equations 1 and 2, B sin C is equal to C sin B. Dividing both sides by sin B and sin C, we shall have C over sin C is equal to B over sin B. Therefore, A over sin A is equal to B over sin B and is equal to C over sin C. Equation 3. Equation 3 is the sine rule. It is instrumental in finding the sizes of angles and sides of any triangle. Example 1. Find the side and angles in the figure below. In our solution, applying the sine rule, 6 over sin 70 is equal to 5 over sin B. And we have sin B is equal to 0.781, and therefore B is 51.54 degrees. Angle A is given by 180 minus the sum of the other two angles, since the total sum of angles of a triangle is 180 degrees. Therefore, angle A is 58.46 degrees. A over sin 58.46 is equal to 6 over sin 70, and applying the same calculations, A is equal to 5.44 centimeters. Now consider the figure below. R is the radius of the circle. Line ON perpendicularly meets BC at N. BN is equal to CN, and therefore sin theta is equal to a half A over R, which is also A over 2R. Hence, 2R is equal to A over sin theta. Equation 1. Recall that angle BAC is equal to angle BOC because the angle subtended by an arc at the circumference of a circle is equal to half the angle subtended by the same arc at the center of that circle. Therefore, theta is equal to angle A because theta is half BOC. If theta is equal to angle A, then equation 1 can be written as 2R is equal to A over sin A. It can therefore be concluded that A over sin A is equal to B over sin B, which is equal to C over sin C, and this is equal to 2R. Take an example. An arc of a circle measuring 8 centimeters subtends an angle of 60 degrees on the circumference of the circle. Find the circumference of that circle. We make a sketch of the figure described above. From sine rule, 8 over sin 60 is 2R, and we find R is equal to 4.62, and we apply the formula for finding the circumference of a circle now that we already have R, and it is 2 pi R, and the circumference is 29.03 centimeters. Let's jump over to cosine rule. To start off, consider the figure below. AN meets BC at N perpendicularly. ABN and ACN are right-angled triangles. By Pythagoras' theorem, triangle ACN, b squared is equal to h squared plus a minus x squared, which means b squared is equal to h squared plus a squared minus 2ax plus x squared. Equation 1. Considering triangle ABN, c squared is equal to h squared plus x squared. Therefore, h squared is c squared minus x squared. Equation 2. Substituting h in 1, we have b squared is equal to c squared minus x squared plus a squared minus 2ax plus x squared, which gives us c squared plus a squared minus 2ax. Equation 3. Cos b is equal to x over c, since x is equal to c cos b. Substituting x in 3, we shall have b squared is equal to c squared plus a squared minus 2ac cos b. Equation 4. Equation 4 is the cosine rule. It can also be shown that a squared is equal to b squared plus c squared minus 2bc cos a, and that c squared is equal to a squared plus b squared minus 2ab cos c. Finally, let's take an example of cosine rule. Find the size of angle B in the triangle below. According to the cosine rule, A is equal to 4 centimeters, B is equal to 9 centimeters, and C is equal to 7 centimeters. B squared is equal to A squared plus C squared minus 2AC cos B. Substituting in the values and finding the missing angle, cos B is 0.5714, and finding the inverse of that, we have B is 34.85.
This is my own and my soul. This is my own. I have a goal. I believe I will succeed in my goal. This is my own.
Islington College.